Alright, hello there. This is video 2 and this is 4.2 notes. Our goal today is going to be, we're going to be able to multiply two matrices. Yesterday we took care of addition and subtraction. Today we're going to take care of multiplication. Now, if a matrix is m by n and another matrix is a n by p, then the product of those two matrices will be in m by p. And what I mean by that is I'm referring to the dimensions. So let's say we have matrix A times matrix B, and it's going to equal the product of the two. Now, matrix A we said is a m by n matrix, and matrix B was an n by p. Now, in order to multiply matrices, there's two very important pieces. The first is these absolutely positively need to be equal. In the event those aren't the same, we say that it's not defined and you cannot multiply those matrices. Now, the first and the last are going to be the resulting dimensions of your new matrix, of your solution. Alright, so let's practice this. It says, describe matrix products. State whether AB is defined. If so, give the dimensions. So we have a 2 by 4 and a 4 by 3. Are the 4s equal? They sure are. Therefore, this product would be defined as a 2 by 3 matrix. So although it's 2 by 4 and 4 by 3 are the two sizes you're multiplying, the resulting matrix, your solution, will be a 2 by 3. In part B here, we have a 4 and a 1. 4 and 1 are not equal, therefore the product of AB is not defined, we say. The product would not be defined. Alright, then over here again, we have a 2 and a 4. Those are not equal. Even though the outer ones are, it is not defined. Okay, so let's try this. Now, finding the product of two matrices. So the first thing we must check is it the right size? Well, here we have 1, 2, 3 rows by 2 columns, and over here we have a 2 by 2 square matrix. Well, our 2's work out, so my resulting matrix is going to be a 3 by 2. Now, sometimes people like to draw a picture to remind themselves what exactly it's going to look like. So we have 3 rows and 2 columns. 3 rows by 2 columns. Alright, now, for the fun stuff. When multiplying two matrices, we are going to go row by column, row by column, row by column. So, to start, I'm going to take my first row and my first column. Those are the only 4 numbers we're dealing with now. So I'm going to take my first entry, which is -1, and I'm going to multiply it by the first entry in the other column. So 1 times 4, and then I'm going to add it to my second entry and multiply that by the second entry in the column. So row by column, row by column. Now we're going to go on to the second row. We're going to take the second row and do the exact same thing with the same column. Alright, so I have 5 times 2, 5 times 4 plus 2 times 6. Alright, as you can see, I just made a small mistake there and I fixed it, but this can get tricky. So the third piece is now we're going to take the third row by the same column and do that process again. So I have 0 times 4 plus -4 times 6. Alright. So now those sums are going to represent the solutions in that row. Alright, now for the second piece. Now we're going to do the same process, only this time we're going to start with the first row by the second column. So I'm going to take -1 times -3 plus 5 times 8. Then I'm going to go second row. Sorry, let me switch colors. Second row by second column. And I get 5 times negative 3 plus 2 times 8. And then I'm going to take my third row by my third column. And I get 0 times negative 3 plus negative 4 times 8. Now, since it's the first time we're doing this, we're going to show all our work like this just so we get the hang of it. But after we do this for probably by tomorrow, you should be able to do some of this in your head, row by column, and get the entry. So it won't take as long to complete each problem. Now, one way I like to check is 4s, 6s, negative 3s, 8. Everything matches down. And then these numbers are just a mirror image of one another. Negative 150, negative 150, 5, 2, negative 4, 5, 2, negative 4. If for some reason something doesn't match, we made a mistake. Alright, so now all we do is do the math. Negative 1 times 4 plus 30 gives me negative 4 plus 30. Now I'm here. 5 times 4 is 20 plus 12. 0 plus negative 24. So to the second row, negative 1 and negative 3 give me 3 plus 40. Negative 15 plus 16. And 0 plus negative 32. Then continue to simplify even further. And I get 26, 32, negative 24, 43, 1, negative 32. Double check. Is my resulting matrix a 3 by 2? It sure is. And that's it. Alright, let's try another one together. So now I have a matrix A is a 1 by 3 and matrix 3 is a 3 by 1. Alright, well our middle dimensions match. Therefore, my resulting matrix will be a 1 by 1. Alright, so we're only going to have one entry in my resulting matrix. Alright, so let's do this. So I'm taking row 1 by column 1. So I get 8 times 4 plus row 2 times column 2, 0 times 6, plus row 3 by column 3, negative 4 times negative 3. Simplify your matrix. And I got 32 plus 0 plus negative 12. I'm sorry, plus 12. We have a negative 4 times negative 3, which gives me a positive 12. So my resulting matrix is a single entry of 44. 32 and 12 give me 44. Alright, what I want you to do is try the next one on your own. We have a 2 by 2 and a 2 by 2. So my resulting matrix is going to be a 2 by 2. Alright, so what I'm going to do is I'm going to put the solution in the right corner here. Negative 15, negative 2, negative 10, negative 4. Please do the work on your own and bring the solution. Make sure you can get that correct solution before class tomorrow. Now tomorrow in class we're going to kind of explain why we do it this way, why the multiplication works this way and we don't just go straight across like when we add and subtract. Alright, there is reasoning. And then we're going to do some more challenging problems and learn how to use our calculator to best suit us. Alright, thanks. See you tomorrow.